Density and specific gravity. We'll be working with two triangles. We have our mass divided by our volume to find our density, or we have a density found by taking a mass divided by a volume. If we're looking for volume, we need the mass divided by the density. A density is any mass, grams, pounds, ounces, any unit of measurement for weight divided by a volume. So this could be cubic inches, cubic feet. It could be a capacity such as liters, any volume, any specified amount of the substance. For a specific gravity or relative density, we're taking the density of our object or gas, and we're dividing it by the density of water or air. Now, density is also a mass divided by volume. So it might help to think of this as density or mass divided by volume of our object divided by the density or the mass divided by volume of water. If we are looking at a solid object or liquid, we're going to be compared to water. If we are working with a gas, we're going to be comparing it to air. So to find the specific gravity of something, we need to take the density of our object, or the mass divided by volume, and divide that by the density of water, or the mass divided by volume for water. If we're looking for the density of water, we can find that using the density of our object divided by the specific gravity. If we are looking for the density of our object, we can use the density of water times the specific gravity. Now, for pipe trades, we need you to memorize everything water related. We need to know that water is 62.4 pounds per cubic foot. We need to know that a cubic inch of water weighs 0.0361 pounds. And we need to know that 0.433 pounds per inch squared per foot is a density. This is what we use for our pressures. When we're comparing our object to our water, we get that specific gravity. If we only have the mass of our object and we have a specific gravity, we can use the specific gravity to find that mass in water. We can do this because we know that the volume isn't going to change. We may not know what the volume is, but we know that using this formula, this volume for the object and this volume for our water are going to be equal. So we can do our mass divided by the specific gravity to find the mass of water. Now, once we have the mass of water, we go back to our density of waters that we must have memorized, and we can find out what the volume is. So in our practice question that we're going to do for this assignment here is that we have an object or a material that weighs 1,251 pounds. So I have a relative density or specific gravity, but I don't know the volume of my object. However, as we discussed, because I have a specific gravity right here, and I have the mass of my object, I know that my volumes are going to be equal in this equation. So I can use my mass divided by the specific gravity to find the mass of my water. If we look at the equation down here, we're looking for the mass and volume of our water, but we know that this volume and this volume are the same. So I have my mass divided by the specific gravity. So in this case, I take my 1,251 pounds, and I'm going to show it as multiplying by the inverse, 1 over my specific gravity of 4.5. Now, ultimately on our calculators, this is going to be 1,251 divided by 4.5, but this is our specific gravity. This is our ratio of our mystery material compared to water. And that's going to give me a number. So on our calculators, let's plug in the following. I hit 1,251 divided by 4.5, and that gives me the answer of 278. I look at my equation here, I have pounds, so now I have pounds. We did the specific gravity of our object divided by water, so now I know that this mass is for water, just like our starting mass was for our object. So now that I know the mass of the water, I can take this mass and I can apply it to the density formulas. We must know these densities for water. So this density here, we must memorize this for water. So we have this value. It never gave us this value, but we have this value. If you're in a multiple choice test, they will have options such as cubic feet or cubic meters or whatever units they want. We would have to use one of those densities. In this case, we know we're working with pounds. So the density, we could pick any one of these. I'm going to pick cubic feet for this one. So I take my mass of water of 278 pounds. I'm going to draw that a little bit more clearly, pounds. And remember that this is water. And I'm going to divide this, or multiply by the inverse, the density. So 278 divided by, and I'm picking cubic feet here, so I'm going to use cubic feet per 62.4 pounds. Now remember, this is just another way to write 278 pounds divided by 62.4 pounds per cubic foot. We do it this way because it shows our units clearly, and I have pounds, and I am left with my units of cubic feet on top. So when I look at my answer, I can do cubic feet, and I know I have a unit of volume. So I'm going to go to my calculator, and I have 278 pounds, and I'm still doing a divide by 62.4, and that gives us an answer of 4.45512. So I'm going to look at that 2. It rounds down. So the most accurate way to show this number is 4.4551 cubic feet. Now, going back to our question, we started with a mass of an object and a specific gravity. We didn't know the volume, but we know that the volume of our object must be the same as the volume of our water in this comparison. So I know for my question here that the volume of my object is also going to be equal to 4.4551 cubic feet.